Good morning, everybody, and welcome to the CEIA Maths tutorials. This week we have Geometry of the Circle with Deirdre de Valish.
A little bit about myself. I'm an electronic engineer. I've had a very mixed and varied career to date. I've worked as a researcher in Tyndall down in Cork. I have worked in industry to design components for cable television systems, and right now I'm working in my local community to develop renewable energy projects. So the one message I suppose I can share with you all about engineering is that it allows for a lot of flexibility in careers if that's what you're looking for. So today we're going to work on the geometry of the circle. I'm just going to set up my pen here. One moment. The right color, lovely. And we're going to start with the equations of the circle. So today's tutorial is going to deal with the fundamental concepts of the circle, which will give you about 80% of what you need to handle questions on the circle. I can't say that in 2.5 hours we'll cover everything, but it will certainly cover the key concepts, if you like. So one of those is, of course, the equations of the circle. The equation is simply a mathematical sentence that will help us describe the circle. It will help us locate the circle in space, and it will tell us how to draw it. So the two main things that you need to know to construct a circle is you need to know where it is. So you need to know the center of the circle, and you need to know how big it is. So you need to know what the radius is. We're going to take the special case first of the equation of a circle with the center at the origin. So if it's at the origin, the center point is 0, 0, and it is some radius r. Now, what we can see here is we can form a right-angled triangle. And in that right-angled triangle, what we have is we have the hypotenuse is equal to the radius. It's the longest side, and it's the one opposite the right angle. And the other two sides are the distance x. Sorry, I'll go back there. And the distance y. Okay, so when we look at that, we are talking about our old friend Pythagoras, who pops up in an awful lot of places. And Pythagoras says that the radius r is the hypotenuse here, and that the hypotenuse squared is equal to the sum of the squares of the other two sides, which we have determined is x and y. So we see this more commonly written as, for the circle, as x squared plus y squared equals r squared. So that is simply how we derive the equation of a circle. It is coming from Pythagoras and the right-angled triangle. Of course, not all circles have their center at the origin. So we need to place the circle at some center, HK, we call it. And we again have our right-angled triangle here, but this time the lengths of those sides are x minus h and y minus k. So that gives us a more general equation of a circle. And that general equation still uses Pythagoras' theorem. And this time it's x minus h squared plus y minus k squared is equal to r squared. And then once we know the center and the radius of a circle, we can apply it to this equation and we can find the equation of any particular circle. I'm going to take that equation now and I'm going to expand it out. So that's simply multiplying x minus h by x minus h plus y minus k by y minus k is equal to r squared. When I multiply that out, I get this equation. Now I realize that this is where things could speed up a bit. You'll have all of the notes so that you can see, you can work through the expansion of this in your own time. I'm tidying up the equation here. and I have placed the x squareds and y squareds at the start, terms with x and y in the middle, and then at the end here I have combined all of the terms that are not dependent on x and y, and those terms would be some constant c. So that constant c can be written like this, but what I'm interested in is extracting r from that portion, because I want some formula to calculate the radius. So when I rearrange this equation here, what I get is r is equal to the square root of h squared plus k squared minus c. Now, the reason I wanted to do that expansion is I wanted to relate this equation here, the equation of this equation, to the other one in the mathematical table. So when you look at page 19 of your mathematical tables, you're given two equations for the circle. This one here, which we derived using Pythagoras, with the center HK. Now, what you have as well is you have another version of the circle, but this time the center is at minus g minus f. So the reason I expanded this one on the previous page was to show that it's simply, this one is simply derived from this one, and this is the, it's applying minus g minus f. And I think it's just because they don't like minuses in equations, and that's what we ended up with when we expanded the earlier one. So what it looks like is minus g minus f, which is counterintuitive really, that minus g minus f minus p might be in the first quadrant. But we get this general equation for a circle when we apply minus g minus f as the center. We can calculate the radius using the formula given on the tables, which is r is equal to the square root of g squared plus f squared minus c. And if we're given the equation of a circle, we can determine the center point of that by the fact that it's minus g minus f. Now, what I'm going to do is some examples just to make it clear what all of that means. So exercise 1, find the equation of the circle with center at 0, 0 and radius length 5. So what that means is we can apply the special case, which is just x squared plus y squared is equal to r squared. Applying that special case, we simply need to insert the square root of 5 in place of r in the equation. And that gives us the equation of the circle as x squared plus y squared is equal to 5. Moving on to exercise 2, they want us to find the equation of the circle S1 with the center at 0, 0 and containing the point 1 and 4. So you remember I said at the start, to find any equation of a circle, we need two things. We need to know the position of the circle, we need to know its center point, and we need to know the radius. So this time we haven't been given the radius, but we've been given a way to work out the radius. And what it says is that the point 1, 4 is on the circle. Therefore, it must satisfy the equation of the circle. That means that we can insert 1 in place of x and 4 in place of y. And that will allow us to calculate the radius. So we'll get r squared is equal to 1 plus 16. R squared is equal to 17. R is equal to root 17. Applying that into this equation here, we will see that the equation of the circle is x squared plus y squared is equal to 17. And we see that. So exercise 3, find the coordinates of the center and length of the radius of the circle. So these are very typical, I suppose, part A questions for the Leaving Cert exam. you will either be given some information about the circle and asked to calculate its equation, or you'll be given the equation and asked to find the center or the radius of the circle. So taking a look at the equation here, what we need to do is go to our mathematical tables again, and we need to match it up to the general equation. And what we are doing here is we are comparing h and k in the general equation to the equation we have been given, and r as well. We're going to be very careful with the minus signs in this. We're going to take the full minus sign. We're going to say minus h is equal to plus 1 in this case. And that means h is equal to minus 1. Going to say minus k is equal to minus 3. Therefore, k is equal to 3. And that gives us the center of our circle. Minus 1 and 3. The next thing then we need is to work out r. We can see that r squared is equal to 16. Therefore, r is equal to root 16. So that's using the first type of equation. Sorry, apologies, r squared. R is equal to root 16, therefore r is equal to 4, just to complete that better. Exercise 4, taking the other version of the equation. How do we extract the center and the radius from this one? So this time we know we're looking for minus g and minus f. Again, we're going to compare it with the general equation given on the tables. What we can see here is that 2g is equal to minus 2. That means g is equal to minus 1. But remember, we're looking for minus g for the center in this one. The next comparison is 2f is equal to 4. That means f is going to be equal to 2. And looking for minus f, we get minus 2. So in this case, the center of our circle is 1 and minus 2. Now we're looking for the radius, and again, in our tables, we're given the formula to calculate the radius from this format of the equation. That's r is equal to g squared plus f squared minus c. So populating that, g we know from here is minus 1. So we pop that into the equation here. From here we know that f is equal to 2, and we're going to square that. Minus c now, so we know that c is equal to minus 11. Therefore minus c must be equal to 11, and that's what we're popping in there. That allows us to calculate r. Again, r is equal to the square root of 16, which leaves r equal to 4 in this case. So that is generally what we need to do with the equation of a circle. We need to either take information about that circle and generate the equation, or we need to take the equation and extract information about the circle. I'm going to go through 3 geometric properties of the circle now, and these are all helpful properties to, I suppose it's tools to use to help address questions on the circle. So each of these tools are a piece of information that you can extract from a question. to help you find the answers that you're looking for. And we'll see them dotted through various examples today. This is probably the key one. The perpendicular to a tangent at the point of contact passes through the center of the circle. So what does that mean? That means that the tangent and the radius are always perpendicular to each other. And that piece of information can generally be very, very useful when trying to solve circle questions. What it tells us is the slope of the radius, if we call that MR. The slope of the tangent, we'll call that MT. So MR is perpendicular to MT, and that means the slope of one by the slope of the other, if you remember from the geometry of the line last week, is equal to -1. In practice, what does that mean? That means that if you know the slope of the radius, if the slope of the radius is equal to 2/3, then to be able to multiply that by the slope of the tangent to get -1, the slope of the tangent must be equal to this inverted, 3/2, and you need a different sign because minus by plus will give you a minus. So if you know the slope of one, you can easily determine the slope of the other simply by turning it upside down and changing the sign on it. So property number 2, the perpendicular from the center of a circle to a chord bisects the chord. So that means that the distance AM is equal to the distance MB. Those two lines are equal. Where that can be quite useful is that you may be looking for a particular point and you might see that what you have here, because it is the perpendicular, again you'll have a right-angled triangle there, and Pythagoras could come into play again to help find the length of sides here or the length of the radius for that circle. Property number 3 then is a corollary to the one that we've just looked at. So if you draw the perpendicular from a chord, then it will contain the center of the circle. So what we see here is this line L bisects the line AB. So these two sides are equal. And it is the perpendicular bisector, so you have a right angle here. The M is the perpendicular bisector of BC, so you have the same on the other line. And then the point of intersection. So if you can get the equations of both those lines and find the point of intersection, then you have the center of the circle. Where this is extremely useful is when you are given 3 points on a circle and you're looking for the equation. Remember I said that to find the equation of a circle, you'll have to be able to find the center and the radius. So this property is a really useful one if you're given 3 points on a circle and you need to find the equation, because you'll have to find the center of the circle first. I'm going to put a lot of focus on tangents in this tutorial today because they play a large feature in the Leaving Cert curriculum, and they're I suppose they're embedded within it. It's difficult to find a question that doesn't have something to do with a tangent. So, tangent properties. A tangent touches the circle at one point only. And we've already seen that the slope of the radius multiplied by the slope of the tangent is equal to -1 because they are perpendicular to each other. With tangents, we're generally asked to prove if a line is a tangent to a circle. And there are two methods to doing this. And one of the things I suppose about studying honours maths is to have an understanding, an in-depth understanding of how to save time in exam questions. So the two methods here, it's important to recognize, are you being asked to find the point of contact? If you're not, then you can use a less time consuming method to prove that a line is a tangent to a circle. What you can do in that case is that you can determine the radius of the circle, and then you can find the perpendicular distance between the line and the center of the circle. If that's equal to the length of the radius, then the line is a tangent, and you have proved that it is. You do not need to progress to find the point of contact. If you are asked for the point of contact, then you would use the second method, and that is to solve between the two equations. So you'd be using a substitution method, and that's certainly more time consuming. So that's very key to be able to identify here where you can use time-saving methods. So I'm going to work through exercise 5. I'm going to work through with both methods so you can clearly see the difference. We have a line which is 2x minus 3y minus 27 is equal to 0. And we want to prove that it's tangent to the circle x squared plus y squared minus 8x plus 4y plus 7 equals 0. Now I'm going to give you a little bit of time here to determine what is the center of that circle and what is the radius of that circle. And you can refer to exercise 4. It will be the same as that. The center was 4 and minus 2, and the radius was root 13. Okay, so we're going to use method A because the question simply states to prove that the line is tangent to the circle. So referring back again, you may have covered this last week in the geometry of a line. We have in our tables on, again, page 19, the formula to calculate the perpendicular distance from a point to a line. So the line that we're interested in is the tangent, and the point that we're interested in is the center point. So in this case, A is going to be 2, B is going to be minus 3, and C is going to be minus 27. X1 is 4 and Y1 is minus 2. So when we populate that equation, we get these numbers. And I'm glad I don't populate these in real time, because I would be bound to miss a minus or do some sort of slip up. You do need to be careful populating formulas. I would always advise being very clear that, you know, A is equal to 2, B is equal to minus 3, write it down on the side and be careful populating formulas. That works down to 8 plus 6 minus 27 over the square root of 4 plus 9. And working that out further, we get minus 13, the modulus of minus 13 over square root of 13. Now the modulus of minus 13 is simply 13 over the square root of 13. And 13 can be written as the square root of 13 multiplied by the square root of 13 over the square root of 13. So we cancel those, and what we are left with is the square root of 13. Now, it's really important in any question in maths to always come back and state what you have just proven. It's not sufficient to simply leave the square root of 13 there. You really need to state that you have proved that the perpendicular distance from the point to the line is equal to the radius Therefore, the line is a tangent. I've done a little bit of correcting of exam papers, and I've seen that there can be, for the completion, for stating what you've proven, there's certainly 1, if not 2 marks at the end of each question. Now, that certainly adds up if you're talking about 2 papers full of questions. So always complete and always state what you have just proven. Now, to take a look at the second method. So the difference here is that prove that this line is tangent to the circle and find the point of contact. So we don't have a choice here. We have to go into the substitution method. So we're going to solve between the 2 equations. We will take the line and we will rearrange it so that we can substitute out x in the circle equation. So rearranging the line gives us x equals 3y plus 27 over 2. Now, this is quite a long expansion, but you do have this worked out in your notes. I am simply placing x here and x here. So it's kind of algebra on that, so I will rush through this a bit. I'm multiplying out the square, and I have multiplied, oh, actually, did I have a little, just to go in here, I had a little error on the notes. I will be sending the notes out with solutions afterwards and I will correct it. I should have had that -8 in there. I have multiplied it out properly here, so we're okay in the rest of the notes. So what I've done there then is multiply across by 4 to remove the fractions. And that's a multiply by 4. And then I'm starting to tidy up the equation. I'm reducing it down to 13y squared plus 130y plus 325. My tables aren't so good that I know that 13 goes into 325, but I know it certainly goes into these 2, so it's worth checking if it does go into 325. And yes, it does, so that tidies up very nicely to y squared plus 10y plus 25. I have a quadratic equation here. So what I need to do to solve that is to use factors. And factors here will give me 13y plus 65 multiplied by y plus 5 equals 0. One of the biggest favors you can do for yourself is be very, very comfortable with getting factors, because it is embedded in every topic in maths nearly. There is going to be something where you need to solve a quadratic equation and you're going to need to do it with factors. So we have, that gives us y is equal to minus 65 over 13, which is equal to minus 5. And on the second here, we just simply get y is equal to minus 5. Now you can see these are the same. So we have only found one solution for y, which is great because there should only be one solution. If it is a tangent, there is only one point of contact. So we shouldn't be getting 2 different solutions for y there. We take y equal to minus 5 and we insert it into the equation we had previously for x. And that will determine x. First, we're getting x is equal to 6. And again, we need to state that 6 and minus 5 is equal to the point of contact. Don't simply leave it as y is equal to minus 5 and x is equal to 6. Finish it off by saying what the point of contact is. Okay, we're going to take a look at 2 special cases now of tangents. And this is where the tangents are either the x or the y axis, because that gives us an extra little piece of information to solve the puzzles that we are given. So x-axis is tangent to the circle. And in this case, what we can see is this is the radius here. And this radius is the same distance as f. We know it's f because it's coming from this point here. So what does that mean? That means that if we take the equation again from our tables page, where r is equal to g squared plus f squared minus c, we can insert f in place of r, and when we work that down, we square both sides. We get f squared is equal to g squared plus f squared minus c. And when we rearrange that, we get g squared is equal to c. So that can be very, very useful if we're given a few points of information about a circle and we can eliminate one of the unknowns in the various equations. So when we know that x is a tangent to the circle, we can either eliminate c or g squared from the equations, and we could end up with two unknowns. And I'll certainly be explaining how this works in some examples. So if we take the case of where y is tangent to the circle, in this case, the radius here is the same distance as g, and we're getting that from the g coordinate of the center. So again, we take our equation for the radius, and this time we're substituting with g. We work that down, we square both sides, and really what we're seeing is, these cancel each other out, and f squared is equal to c. Okay, so where was I going with that? Generally, what we're given is a length. We're given some information about the circle, generally 3 points of information. And those 3 points of information allow us to form equations in terms of g, f, and c. And if we have 3 unknowns, we need 3 equations. We can solve the 3 of them, and that allows us to find the equation of the circle. And that's what I'm going to work through in exercise 6 here. So a circle of radius length root 20, there's our first piece of information, contains the point -1 and 3. There's our second piece of information. And its center lies on this line. There's our third piece of information. Now in this exercise, it's saying find the equations of 2 circles that satisfy these equations. Okay, so apologies, the notes are just slightly off there, but I hope you can read them. The first step is we know what the general equation of the circle is. And the second is we know the radius length. So the first equation that we can form is g squared plus f squared minus c is equal to the radius. And that's the square root of 20. If we square both sides, what we get is g squared plus f squared minus c is equal to 20. And that's our first equation. Step 2. We're told that -1 and 3 belongs to the circle. That means that -1 and 3 satisfies the equation of the circle, which means we can place -1 and 3 in place of xy in the general equation of the circle. And when I do that, I get another equation in terms of g, f, and c. And that works down to -2g plus 6f plus c is equal to -10. So that's our second equation in terms of g, f, and c. Now I've just taken both of those and written them up here, so we have them for easy reference on this slide. The third step then is we are told that the center belongs to the line x plus y equals 0. So that means we can replace g and f, we can replace x and y, sorry, with minus g minus f. So we get this equation, minus g minus f is equal to 0. And that can be rearranged to say that f is equal to minus g. But that's very useful because we can do a very easy substitution into some of the others. So step 4 here is we replace f in equation 2. And what that leads to is, so we're replacing f here with g. So we have minus 2g minus 6g plus c equals 10. And that gives us c is equal to 8g minus 10. So that's a fourth equation that we can work with. The next step is to replace c and f in equation 1. So this was equation 1 and this was equation 2. So we're going to replace c and f here so that we get an equation that only has g in it. And that leads us to g squared. F squared gets replaced by minus g, and c gets replaced by 8g minus 10. So working that out, we get 2g squared minus 8g plus 10 equals 20. Two g squared minus 8g minus 10 equals 0. And that gives us another quadratic equation. So here we are back to needing to use factors to solve this. Just writing that equation up there again. And if we get our factors, we can get g plus 1, g minus 5 equals 0. I'm not going into the detail of getting factors here, so I hope you're very familiar with that process. And what we get is g. I should really be saying g plus 1 equals 0 or g minus 5 equals 0. That gives us g equals minus 1 and g equals 5. That's great. We now have two solutions for g. And if you remember at the start of the question, we were asked to find equations of two circles that satisfy those conditions. So what we want to do is we want to look at case 1. And again, I'm just bringing up there the previous equations 3 and 4 that we had, because that will help us obtain f and c from the solutions to g. So when in case 1, when g is equal to minus 1, coming from 3, we know that f will be equal to 1. And coming from 4, we know that c will be minus 18 in that case. So what we need to do is we need to take our general equation for a circle, and we'll get x squared plus y squared minus 2x plus 2y minus 18. And that's the first circle. So then we work out case 2. Case 2, g is equal to 5. Therefore, f is going to be equal to minus 5. And c will be 30. I'll give you a few moments there maybe to just generate the equation for circle 2 by inserting g, f, and c into the general equation for a circle. I don't have a poll for this, Eamon, but it's just a bit of time for people to catch their breath, as I know that when the calculations are written already on the screen. Need a little bit of processing time maybe. Okay, so circle 2 in that case gives us x squared plus y squared plus 10x minus 10y plus 30. Now, still on tangents, as I said, there's a lot of material on tangents. It forms the basis of many, many different questions, and there's so many different ways of looking at them. This one here is another one that's going to rely heavily on the fact that the radius from of the circle is always perpendicular to the tangent at the point of contact. I can't stress that enough, and I'll probably say it another 10 times before we finish the tutorial today, but it really is one to remember. So a very common question is to obtain the equation of tangents from a point P not on the circle. So we're going to take a look at how to deal with this. And here, in case I haven't stressed it enough, remember the perpendicular distance from the center of the circle to the point of contact is equal to the radius. So from last week and the equation of the line, actually I say page 19 there in our tables, it's actually page 80. We know that the equation, the general equation of a line is given in the form y minus y1 is equal to the slope multiplied by x minus x1. So how do we approach this? What's our method? We know that the point x1, y1 will satisfy the equation of both tangents. We know that the perpendicular distance from the center of the circle to the tangent is going to be equal to the length of the radius. So we are going to use both of those pieces of information to form the equation of the tangents. What we do is we're going to calculate m, and then we're going to write down the equation of the tangents. Once we have m, we can use the general equation of a line to form the equations of the tangents. So it's best explained in an exercise. So find the equation of the tangents to the circle x squared plus y squared plus 4x minus 2y minus 4 is equal to 0 from the point P, which is 3 and 1. So the first thing we're going to do is calculate the center and radius of the circle. Again, I'm going to give you a few moments to do that, and we'll see who's still with me. Doing maths is a bit like exercising muscles. The more we do it, the simpler it becomes, and the more pain-free. So it's always good to take every opportunity to exercise that muscle. A few people got caught out there maybe with the minuses and pluses, and maybe just watch the square root as well, the r squared on that. So what the answer is minus 2 and 1, which is minus g minus f. So what we have here is 2g is equal to 4. Therefore, minus g would be equal to minus 2. We have 2f is equal to minus 2, and therefore f is equal to minus f is equal to 1. And then I won't work out the radius there, just be careful that r is equal to the square root of g squared plus f squared minus c. So what that gives us is the radius is equal to 3. Okay, so that's step 1. Step 2 then is the general equation of a line is going through the point 3, 1. So we're going to take that general equation of the line, which is y minus y1 is equal to m into multiplied by x minus x1. So this is our x1 and this is our y1. And we replace that in the equation. And what we get is y minus 1 is equal to m multiplied by x minus 3. Now we can multiply that out and bring everything to the left-hand side of the line. In our format, we're normally used to seeing the x's first. So it's written in the form ax plus by plus c equals 0. There's our x term, there's our y term, and all of this is our constant term. But now what we have is we have the equations of both of those lines, but each of them will have a different slope. So what we're going to need to do is to work out those slopes. Now, this is where it's so important to know that if we can calculate the slope of the radius, then we're going to be able to calculate the slope of the lines as well. So step 3, we know that the perpendicular distance from the center to the first tangent PA is equal to the radius, and we know that the perpendicular distance from the center to PB equals the radius as well. And that can be using the formula on the tables, we can place it equal to 3. The line in question is the equation for both of those tangents, and therefore we can say that A is equal to m, B is equal to minus 1, and C is all of this term here. The center that we're interested in is, or the point that we're interested in, the x1, y1, is going to be minus 2 for x1 and 1 for y1. So when we populate that into the formula, we get something that looks like this. Again, be super careful when populating these formulas. So always use your brackets around your negative numbers, and just take a bit of time with those ones, because simple slip-ups can cause unwieldy numbers down along the line and cost a lot of time trying to make calculations. In general, the questions you get will resolve with relatively simple numbers, because what you're being assessed on here is your ability to follow through on the method, not whether you can multiply 153 by 2.35. So just if you're very, very careful with your negatives, you will generally see relatively simple numbers fall out as you work down through the calculations. That tidies up to the modulus of minus 2m minus 1 plus 1 minus 3m over the square root of m squared plus 1, and that's all equal to 3. Now, and that tidies up even further to the modulus of minus 5m equal to 3 over the square root of m squared plus 1. Now, an important thing I want to point out here is just dealing with modulus and dealing with an unknown inside in the modulus. So what we have here is we have to square both sides, because if you have the modulus of x is equal to 5, you don't know what x is. X could have been 5 or it could have been minus 5. So there are two options for x. And the easiest way to deal with that is simply to, because we know that the answer to that is to x squared has to be a positive. There's only one answer to it. So when we have an unknown inside a modulus, the way to deal with it is to square both sides. Then we know that the answer we're dealing with is just one option, the positive option. So that's what I'm doing here. I'm squaring both sides. If I'm being proper, but I should maybe have my brackets in there. And multiply it out and get this. And when I work that down and bring everything over to the left-hand side, I see again that I have a quadratic equation. But this quadratic equation tidies to 16m squared minus 9 equals 1. And there's another kind of important piece of revision here is, can we recognize immediately that this is the difference of two squares? So to get the factors of this, we need to apply that difference of two squares method. And if you remember, it is the first square minus the second square is equal to x minus y by x plus y. That's how you get the factors of that. So remember, we have to write it in proper square format. So it's not 16m minus 9 by 16m plus 9. We have to convert this into square. So 4m to be squared gives us 16m squared, and 3 to be squared gives us 9. So written in this format, we can simply apply this rule, and that gives us the factors 4m minus 3 multiplied by 4m plus 3, and that's equal to 0. So that gives us two options for m. So m1 is equal to 3 over 4, and m2 is equal to minus 3 over 4. And now we can see how that's going to allow us to calculate two equations for the line. So that's our step 4. It's our final step. It's to extract the equations. If we're looking at PB, we know that m1 is equal to 3 over 4, and we know that the equation that we had for it is m1 multiplied by x minus y plus 1 minus 3 m1. And we pop m1 into the equation. Now I'm just multiplying across by 4 to remove the factors or the fractions. That tidies up to this, which goes to a very nice 3x minus 4y minus 5 equals 0. And that's the equation of my first tangent. I'm going to give you a little bit of time now to do the same for PA and to work out the equation of that line. Lovely. 3x plus 4y. Okay. So again, I can see it's about half and half there. It's just that point of being extremely careful with the minuses and pluses. Use the brackets wherever you need to, and possibly maybe some people might have run into difficulty here. You have a minus by a minus is going to give you a plus. And in the tidying up then, I'm multiplying across this time by minus 4 because I don't want to have a minus in front of the x here. So when I tidy, that's what it is. So I think it's just a matter of being extra. Just slow down that, fraction of a few seconds to really watch your minuses and pluses, because it's a shame to have all the knowledge and information about how to calculate the answers, to have it kind of to get it wrong maybe at this point here, which is just a matter of taking a few extra moments to get the minuses and pluses right. Okay, I'm just trying to determine here the best area for a break. What I have is about 2 different sections left, and then I have some exam questions. So I think maybe we'll do one more section and then take a break. That'll probably be about 7 or 8 7 or 8 minutes for this section, and then we'll take a quick break. We'll do the last section, and then we'll go into exam questions. So common tangents and common chords, what are they? If we have two circles, S1 and S2, then when you subtract one equation from the other, what you get is a line, because essentially if you're extracting x squared and y squared from each other, which will be the case in every circle, the squared components will go away and you will be left with an x, a y, and a constant component, which is the format for the equation of a line. So it will represent a common chord if they have 2 points of intersection. So that's what a chord is to the circle. It's a line that cuts the circle at 2 points. It will represent the common tangent if there's just 1 point of intersection. Okay, this is useful information, but how does it work in reality? Again, we need to go into an exercise to see how this works. So this one, exercise 8, says find the equation of the common chord of the circles. So we have two equations, and if we're looking for the common chord, what we want to do is we want to subtract one from the other. So we get the common chord using S1 minus S2 equal to 0. And again, I can't stress enough to be really careful with multiplying through with that minus, because what it's going to give you, that minus has to multiply through all of these terms. So it's going to give you minus x squared minus y squared minus 3x minus y plus 6 when I remove the brackets there. What that does is it tidies down. As I said before, the squared components are simply going to go away, and we will be left with an x and a y and a constant component. And that gives us this equation, x plus y plus 1 equals 0. And that is our common chord. We know it's a common chord because we've been told in this question that it's a common chord. If we weren't told in the question, we wouldn't be sure if it's a common chord or a common tangent. So we found the equation of the common chord, but the next part of this exercise is if we want to find the points of intersection, then we must solve between the line that we've just found and either S1 or S2. So that's substitution again. What we need to do is rearrange the equation of the line. We get x is equal to minus y minus 1. And substituting into, we're going to take S1. I've taken S1 because I think there was no x component in x1. So it just gives me, yeah, there was no x component. So it just gives me a few less seconds of calculation, which can help. So minus y minus 1 squared plus y squared minus 2y minus 9 equals 0. Multiplying that out gives me that, and it tidies up to 2y squared minus 8. We'll get y squared is equal to 4. And if y is equal to the square root of 4, then there are two answers for y. Y can be plus 2 or it can be minus 2. So in the case where y is equal to plus 2, then x is equal to minus 2 minus 1, which is equal to minus 3. So that gives us our first point. And in the case where y is equal to minus 2, x is equal to 2 minus 1, and x is equal to 1. So again, just that bit of finish off what I've been asked to do. The points of intersection are minus 3 and 2 and 1 and minus 2. Really, really important not to leave your answer like this, because there is definitely a mark going for stating the actual points in point format. If you're asked for a point in the question, you will be expected to give a point in the answer, not just this. And what we had was the equation of that line, the common chord was x plus y plus 1 equals 0. And that's what set that x is equal to minus y minus 1 up there. So I hope that clears that up, but don't worry. The notes that you were sent, you have notes without solutions for today, but we'll follow up with this so you'll have a full complete set of notes with all of the answers that you worked through as well today. So you'll have full, and they will be updated because there was a couple of little tweaks that I needed to make, as I said along the way, a few mistakes that were in the original notes too. So the next set of notes you'll have will be fully complete and will have all of the corrected versions. So on to touching circles. Two circles are said to be touching if they have just one point of intersection. So that means that the circles are essentially tangents to each other. And there's two ways that this can happen. They can be touching externally. And in that case, if you add the radius of the first to the radius of the second, you'll get this distance d, which is the distance between the two center points. The second option is if they're touching internally. And in that case, the distance between the two center points is equal to the radius of the first circle minus the radius of the second circle. Now it's the modulus of that because we're looking for a distance. We're not concerned with the direction. We're not concerned about whether it's positive or negative. We just want to know that value. So exercise 9 is we want to show that these two circles touch externally. And so what we need to do is we need to calculate the radius of both circles and we need to add them together. If we add them together, then that distance should be the same as the distance between the two center points of each circle. So what that tells me straight away is that the information we need to solve this exercise is to be able to get the center of both circles and the radius length of each for each circle. So if we look at circle 1, we have a center of 1, 1 coming from this equation here, and we can work out the radius, and that gives us a center of 1, 1 and a radius of root 2. So I'm going to give you all a chance to do that for the second circle now. This is the third time we're practicing this. So as I said, it's all about just that constant repetition exercise. It becomes second nature in the end. You nearly look at the equation of a circle and just spot what the parameters are that you need without having to do too much calculation. That really speeds up the whole process. So just a few moments there for circle 2 to get the center and the radius. So we have the center is 4, 4, and the radius in that case is 2 times the square root of 2. So we want to add both of those radii together. So R1 plus R2 gives us 3 times root 2. And if we want to show that the circles touch externally, what we need now is to find the distance between the two centers. And if they touch externally, then that distance should also be equal to 3 times root 2. So coming from page 18 on our tables and the geometry of the line, we know that we have the distance formula. And that distance formula is x2 minus x1 squared plus y2 minus y1 squared and the square root of all of that. So in this case, we have x1, y1, x2, y2, and we populate those into the distance formula. And we get d is equal to 9 plus 9. And therefore d is equal to the square root of 18. And that breaks down to 3 square root of 2. D is equal to R1 plus R2, therefore the circles touch externally. Again, we've been asked to show, if we ever have that show or prove, that statement at the end is very important. Okay, so as I said, I've tried to put into this tutorial, I think it's probably about 90% of what you will need for the circle. It's not fully comprehensive. There may be other things that you will see in class, but it's certainly the fundamentals that you need to deal with most of the exam questions. So with that now, I'm going to switch over and just pull up another presentation file, and we're going to delve into some exam questions. We'll take a look at 2019. As you know, we didn't have 2020 this year, crazy year that it is. So question 3 in last year's paper. They are telling us that the point minus 2 and k is on this circle, x minus 2 squared plus y minus 3 squared, and that's equal to 65. They're telling us there are 2 possible values of k, where k is a member of the of z, which means it can be a positive or negative integer. So if we just sketch out a circle for ourselves, I'm always a big fan of that. They're telling us that there's 2 possible values, which means that, you know, minus 2 is here along the x-axis somewhere. Say that's minus 2. And then there are 2 possible values for k. So the y-axis there runs through. Or sorry, the y-axis wouldn't be there. The y-axis would be over here, but we'll get two vertical values for k. So that just kind of gives us a visual of what we're looking for. So again, if we know a point is on a line or a circle, then we know that point satisfies the equation. So we can place minus 2 in place of x and k in place of y in the general equation for a circle. And that, or sorry, we don't need the general equation for the circle in this one because we've been given the equation for the circle. So we can pop that into the equation for the circle, and that gives us this equation here. And minus 4 squared plus k minus 3 squared equals 65. And you can see here now that we are getting very close to being able to solve for k. We have to multiply out the square. And this is just bringing the minus 4 squared is 16 plus 16 brought over here is minus 16. Again, just another note to be very careful with the negatives and positives. That breaks down to k squared minus 6k plus 9 is equal to 49. And yet again, we're back to having to solve for factors. It's the biggest favor you can do for yourself is to get quick and speedy at these because they're everywhere. So solving for those, we get k plus 4 multiplied by k minus 10 is equal to 0. And that gives us k equal to minus 4 and k is equal to 10. And that's what we were looking for. We were looking for 2 possible values of k. We're told that k is a member of z, which means that's a valid answer and that's a valid answer. If we had been told that k was a member of n, the natural numbers, we would be discounting k is equal to minus 4 because negative numbers are not part of the natural numbers. If we had found a value of k is equal to 3.5, it wouldn't be part of z. It's just a thing to keep note of. But it is valid because minus 4 and 10 belong to z. So part B now of that question. The circle S is in the first quadrant. So in the first quadrant, that's an important piece of information. There was no word misplaced in these exam questions. Everything is going to have some information attached to it. So the first quadrant tells us that what we're looking for here, for the, say, the center of the circle or any point on the circle, they all have to be positive. And that is actually important in this question, because if we solve and we find negative numbers, they're going to be out in some of the other quadrants. So the first quadrant means every solution we find needs to be positive. So as I said, there's no redundant words in any of these exam questions. It touches both the X and Y axis. So we took a look at the special cases there. So what we know now is the radius is going to be the same distance as both the X and the Y points on the center of the circle. That gives us another little piece of information. We know that, you know, it's either going to be 3, 3 or 2, 2 or 4, 4. X and Y are not going to be different to each other because the radius can't be different at different points. We have the line here, t is a tangent, 3x minus 4y plus 6 is equal to 0. And they're telling us it's tangent to s as shown. And they're asking us to find the equation of s. So again here, we see one piece of information, possibly 2 and 3 pieces of information, and 3. So we've got quite a bit of information there, and we generally need at least 3 points of information to solve for the equation of a circle. So as I mentioned there, we know that because it touches both axes, that the center point is actually going to be the same as the radius, and both the X and Y coordinates are going to be the same. Again, we get our general equation of a circle, and we know that we're going to need to find G, F, and C if we are to get the equation of this circle. G and F, of course, is the center of our circle. So, piece of information one, we know that G equals F equals R. We can use the equation in the tables to substitute for G and F and replace it with R in the equation. And that gives us a nice tidy C is equal to R squared. Now we can rewrite the general equation of the circle, removing G and F and replacing it with R. And that leaves us with the problem where we need to find the radius. Once we have the radius, we have the equation of this circle. Again, we're back to that all-important piece of information. We know that the distance, the perpendicular distance from the radius to the tangent is the same as the radius. Sorry, the perpendicular distance from the center to the tangent is the same as the radius. So we can say the radius is equal to that perpendicular distance formula. What line are we dealing with in this case? We're dealing with the line t is equal to 3x minus 4y plus 6 equals 0. And the point we're dealing with is the center of the circle. So again, it's always good practice to write down exactly what those parameters are before populating the equation. And that is A is equal to 3, B is equal to minus 4, and C is equal to 6. And x1 is equal to R, and y1 is equal to R. Populating the equation gives me this. And tidying it up gives me 6 minus R, the modulus of 6 minus R over the square root of 25 is equal to R. Now, again, we've come across this in the exercises. We need to square both sides when we want to remove a modulus that has an unknown inside it. Small glitch in the notes here again. I should have squared that side as well. And when I multiply out, I'm squaring the top. I'm bringing the 25 up to here to get this. and multiplying out, tidying up, and what we get is I'm bringing it forward to this slide again, so in case you think I'm going very quickly there, when we multiplied all that out, we got 24r squared plus 12r minus 36. We can see that that will divide across by 12 to give me a nice tidy equation. Again, a quadratic, and so we're back to factors, which gives us r plus 3 multiplied by r minus 1 is equal to 0. And that gives us r is equal to minus 3 over 2, and r is equal to 1. Now, remember what I said, no piece of redundant information. We were told specifically that this circle was in the first quadrant. That means that r equals minus 3 over 2 is not a valid answer, so we need to discount it in this case. And we are left with r is equal to 1. And what that means is we now have r. And we can go back to what we had previously, which was c is equal to r squared, when we need to work out c to populate the equation fully. If c is equal to r squared, then c is simply equal to 1. And once we have c and we have r, we can write the equation of the circle, which is s is equal to x plus y squared plus 2x plus 2y plus 1. Okay, so that question brought together a lot of what we were doing in the theory section. It took a look at the tangents being the x and y axis being tangents, and also that all important radius being perpendicular to the tangent as well. And it made us bring those pieces of information together to solve for the equation of the circle. So 2018, then question 5. They're telling us that the line M, which is 2x plus 3y plus 1 equals 0, is parallel to the line N, which is 2x plus 3y minus 51 equals 0. And it's saying verify that the point A, which is minus 2 and 1, is on M. So again, we know that if a point is on a line, then it should satisfy the equation of the line. So the equation of the line is, in this case, it's 2x plus 3y plus 1 equals 0. And the point A is minus 2 and 1. And so I think we can get rid of these. We didn't actually need it for this, but this is important that we are saying for the point A, x is equal to minus 2 and y is equal to 1. All we're doing here is we're putting x and y we're putting minus 2 and 1 in place of x and y in the line M. So that's what we get that here. So just in case that was confusing, I must have thought I was populating the distance equation again. We don't necessarily need that here. When we pop it in, we get minus 4 plus 3 plus 1 equals 0. And we're saying that's correct. We'll end up with minus 4 plus 4 is equal to 0. Again, don't just leave it at that. Say specifically that the point A is a part of M, the line M. So we have shown, we have verified that that is the case. Because if you just leave minus 4 plus 4 is equal to 0, it's not sufficient to just tidy up the answer there. Now, so we have a drawing that was given to us on the on the question. We have the line M and we have the line N, and we have the points A and the points B. So it says find the coordinates of B, the point on the line closest to A, as shown below. So if it's the point on the line closest to A, it must be perpendicular. That's because any other point, if it doesn't make a right angle, it's going to be further away. So that's what that word is indicating. I think I was going to do a poll question there. Apologies, Eamon. I was going to get you guys to work out the slopes of the line, but I've gone a little bit ahead. So we've got the slope of M, and we've got the slope of AB. So I was going to get you to think through working that out. But if we have the line M, we have 2x plus 3y plus 1. So I've just given myself the job. Just to be sure that people are familiar with calculating the slopes, I'm going to rearrange that where y is on its own on the left-hand side. So 3y is equal to minus 2x minus 1. So y is equal to minus 2x over 3 minus 1 over 3. And so what I see there is it's written in the form y equals mx plus c. So the coefficient of the x is our slope, and that's where I'm getting the slope of m is equal to minus 2 over 3. And so we know that AB must be perpendicular to m, and so because we have a right angle here as well. If it's perpendicular, then the slope of AB must be equal to, turn this upside down, and changing the sign is giving me a plus. So that gives us the slope of AB. So we have two slopes, and we have the point minus 2 and 1. If we know the slope and a point on the line, we can calculate its equation. We're using the general equation of a line formula, and populating that, there's our y1 and our x1, and this is our m. And we get y minus 1 is equal to 3 over 2x plus 3. 2y minus 2 is equal to 3x plus 6. And that gives us the equation for AB, which is 3x minus 2y plus 8. That's great. So we have this, and we have also the line N, because B is on N. Oh, I'm going to have to somehow now rub out my little scribblings there. Eraser, so that I can put the rest of the stuff up. So when you see how bad my writing is, I hope you'll appreciate that everything has gone in and typed notes, not to put you all through it. So what we need to do is the point B is the intersection of the line AB and the line N. So we need to simply solve between those two lines. In the point of intersection, when we solve for x and y, that is the point of intersection B. So if you remember from simultaneous equations, we need to try and eliminate one of the terms here so we can solve the equation. And what I'm going to do here is I'm going to multiply the top line by 3, which will give me a minus 6y in the middle, and the bottom line by 2, which will give me a plus 6y in the middle there. That gives these two equations, and it's the y's that I'm going to cancel out. That leaves me with 13x minus 78 is equal to 0. 13x is equal to 78, and can generally breathe a sigh of relief when I get a whole number there for an answer that x is equal to 6. I haven't made a mistake somewhere up along the line with a positive or negative, because it would be very hard to make a mistake here and get a nice whole number at the end here. Now, don't worry, if you do get decimal points or fractions, that happens too. But in general, if you see a whole number coming out, you can kind of breathe a sigh of relief that you likely haven't made a mistake all the way down along the line. If you start running into very complicated numbers, I would say take a quick moment to go back over and check that you've got everything right here. So we just need to find the y coordinate for b now. And we can take either one of the lines and substitute in x. And what we get left with is y is equal to 13. Again, we've been asked to find a point. So the answer we're going to give back is b is equal to 6 and 13. Okay, that is the full question, I think, for 2018. I know there can be parts A, B, and C, but I think that was it, which shows that, you know, what we've done today provided sufficient information to address exam questions. Now, these are 25-mark questions that I'm doing here. 2016, we have question 2 there, and that is a point x has coordinates -1 and 6, and the slope of the line xc is 1/7. So they want us to find the equation of xc and to give our answer in the form ax plus by plus c equals 0. Again, they're telling us that a, b, and c are members of Z. Okay, if we want the equation of a line, we go to the general equation of a line and we take a look and see what information do we need to get that. Well, we need the slope and we need 1 point on the line. Have we got that? There is our x and there's our slope. So this should be fairly straightforward. We're going to populate x1 and y1 with -1 and 6, and we're going to populate m with 1/7. That generates this equation, and it tidies up to, again, very important there that we don't give it in the form y equals mx plus c or any other format, that we give it in the format that we were asked to. So we rearrange by bringing everything over to the left-hand side, and that gives us x minus 7y plus 43 is equal to 0. So now we know what the equation of this line is. And that's part A sorted. So what are they asking for part B? They're saying C is the center of a circle S, and it's got a radius 5 centimeters. Okay. They've introduced the line L here, and they're telling us that it has the equation 3x plus 4y minus 21 is equal to 0. And it's a tangent to S, and it passes through x as shown. Now find the equation of one such circle. Okay, well, straight away, I suppose we know if it's tangent, then we have this right angle triangle here that could be useful to us. There's our right angle. We know this distance. We know this equation, we know this point, and if we're looking for the circle, we obviously need to find C. Okay, so again, it's that perpendicular distance formula, because we know the distance of the radius here, 5, and we know the equation of this line. So we need to find some way to find G and F within using that formula. So that's the route we're going to head down first. We know that the radius is equal to that. And for the line L, we're going to identify our A, B, and C, being very careful with our positives and negatives. to be able to populate this equation. And we know that for the point C, we're looking at the center of the circle. And for now, we just know that that's minus G and minus F. So I'm going to just give you a little bit of a chance to populate that equation, to take these parameters and pop it up into this equation here. Just for practice, because it's better for you than it is for me. So it's just, yeah, to consider that and to pop those parameters into that equation. Okay. Oops, sorry. We had the information r is equal to 5 as well, but that's the right-hand side of the equation. So when we populate, we're going to be very careful again with our negatives, put some brackets around our negative numbers. There's our minus G and minus F going in place of X1 and Y1. And we have 3, 4, minus 21. And when we work that down, this ends up at the square root of 25, and the square root of 25 is 5, so that's where I'm getting this 5 here when I bring it over to that side of the equation. Here, when I tidy up, I get the modulus of minus 3g minus 4f minus 21. Now, what happens there is that I get this. I have unknowns inside in this modulus. And so it's a little bit tricky now because it's not just one unknown, it's two unknowns. And remember before I said to square the modulus if you want to remove the modulus and there are unknowns inside it. If we try squaring that, we'll get a whole pile of gunk. So what we want to do is we want to take a look at both cases. We know that when we remove the modulus, that one possible answer is positive 25, but there's another possible answer that's minus 25. Now, fortunately, the question says to us, find the equation of one such circle S. So solving these will give us two different circles. So we can simply pick the one that we want to solve because we're only looking for one. Remember, again, I said there's literally no redundant word in these questions. So everything is giving you an indication of what you have to do. It's giving you a piece of information. So in this case, I'm going to pick this one and I'm just going to find the circle that's associated with this solution. But you could do it for the other one too. You know, it's totally your own choice which one you want to do. When I tidy that one up, what I get is minus 3g minus 4f is equal to 46. And that's one equation. I can see I have two unknowns, so I'm going to need to find another equation with g and f that I can solve, because if I have two unknowns, I need two equations to solve. If I have three unknowns, I need three equations. So how am I going to get another equation in terms of g and f? Well, the other thing that I know is that that center is also on the line x minus 7y plus 43. So I can put minus g and minus f in place of x and y in that equation. And that will give me my second equation. I have minus g plus 7f is equal to minus 43. So now, two equations, two unknowns. I'm simply solving between the equations and I'm using my simultaneous equations to do that. I take a look at this And if I want to eliminate one, it looks like G in this case is the easiest to eliminate. I'm going to have to change the sign on G. So I'm going to multiply the second line by -3. That gives me this, and it's G that I'm eliminating in this case, which yields -25f is equal to 175. Minus f is equal to 7. I'm simply going to leave it at that here because I'm looking for the center of the circle and I know it's minus f that I'm looking for, so I don't need to go as far as solving for f. So once I have well, actually, I suppose I do need to put f into one of those equations. So if minus f is equal to 7, then f is equal to -7. And so that's what I'm putting into this equation here. I have picked this one just to solve for G. So that gives me -3G is equal to 18 and minus G is equal to 6. So now I have minus f and minus G, and I can say that the center of the circle is equal to 6 and 7. Minus G and minus f is equal to 6 and 7, and that's also equal to h and k. And the reason I do that is I don't want to go and I have the radius. I don't want to have to go and start working out C now to use the second format for the equation. So I can simply use the simple format of x minus h squared plus y minus k squared equals r squared. That is the equation of a circle. I know what the center is. I know what the radius is. I don't have any further calculations to do. So I can say S is x minus 6 squared plus y minus 7 squared is equal to 25. Now, that actually brings me to the end of my material today. Being the first time online, I was unsure about, the length of time it would take. I will say that we have covered an awful lot of material. I don't think I would have got through this much had the tutorial been in person. So if you felt it was rushed at any point, do understand that there's a lot of material gone in there. We've gotten through it in quite an amount of time. I hope you can look back over the videos of this if you need to revisit one that went too fast for you. We will circulate the notes, and I want to thank you all for feeding in where there were errors, because we'll correct those now and you'll have a full set of notes. So if you did miss taking down anything, you will receive the full set and you'll be able to follow along from that.
Thank you, Deirdre, for your geometry of the circle presentation, and we hope to see the students. We hope to see you here again next week for the trigonometry 3 and the complex numbers, the polar form of complex numbers tutorial.